Welcome back to the OpenAI Associate Developer course. In this lesson, we'll dive into the process of function calling within the OpenAI API. Understanding this process will help you effectively leverage the API's function calling features. First, it's important to grasp that OpenAI's function calling is a way to connect the LLMs to external tools and APIs. Because OpenAI's function calling method is somewhat unconventional, it can initially seem confusing. The name function calling suggests that the OpenAI API would execute a function, but it doesn't actually call the function. In traditional software development, calling a function means directly executing a specified function. Therefore, you might expect the OpenAI API to call a function during the LLM's processing. However, OpenAI's function calling feature is different. It acts more like a function pointer in C or a callback in JavaScript. It tells you which function to call and with what parameters. The function calling workflow in the Chat Completion API allows you to provide the OpenAI model with a function's description, including its name, parameters, and purpose. As the LLM processes the request, it determines if the function's information is needed to complete the response. If so, it returns a JSON description with the parameters to use when calling the function on the LLM's behalf. Here's a detailed walkthrough of the function calling process in the OpenAI API. First, call the model with the user query and one or more functions defined in the tools array of the chat completion call. Next, the model determines if one or more of the provided functions are needed. If so, it returns the function's content, such as the function name and arguments, as a stringified JSON object adhering to the function schema. Then, in your application's response handler, pass the AI's response and call the identified API function with the arguments provided by the AI. Finally, after receiving a response from the API, call back into the model and append the response data from the external API function as part of a new message for the AI to process. This allows the AI to provide more precise results. While this process might seem complex initially, it's quite simple once you understand it and see it in action. As you use this powerful functionality more often, you'll become more comfortable with the process. Now that we understand the function calling workflow, let's look at the configuration properties we'll need and the JSON format required to set up the function calling feature. First, add the tools array property to your configuration object. This is an array of JSON objects, with each object containing a single function's schema. This simply means if you want to make 5 separate functions available to the AI, the tools array will have a length of 5, and each element in the tools array will contain a single function schema. Within each function object in the tools array, every object will contain 2 top-level keys, type and function. The type key must be set to the string function, and since it cannot be set to anything else, for TypeScript, we included the asConst modifier. Next, the function object will contain a name, a description, and a parameters object. Note that if you leave the parameters object out, the function will be called without any arguments. First, we'll set the function's name. This is the identifier the AI will use to let you know which function to call, and should be unique. While it is good programming practice to name this the same as the API function you'll call, that isn't a requirement. Remember, this is just the reference the AI uses to let you know what it needs to satisfy the query. Next, you'll fill in the description property. This is a string that explains the function's purpose and use, and may be helpful in letting the AI better understand what the function does. Once we have the function's name and description set, we'll move on and add in the parameters object. Again, if your function takes no arguments, you can omit the parameters object. For our example, we'll include the parameters object, and we'll now look at how to set up the parameters. The first property you need to set in the parameters object is the type property. This is a string and should be set to object. And again, because of TypeScript type safety, we add the asConst modifier. Following this, we need to define the parameters the function expects by placing the parameters into an object which is explicitly named properties. This object is where you'll place the objects which hold the function's parameters. Okay, this is the part that begins to confuse most people. but it's actually pretty straightforward. First, we need to provide a name for the function parameter. However, this isn't done with a name property, but rather by naming the object itself. In our example, the first parameter for the getCarInfo function is carName, and it is a string type. We add in a description property to explain what the parameter is used for, and that's it. Next, we'll add in 2 additional properties for year and top speed. And as with the car name, we supply a type and a description for each of these parameters. One thing to notice, the year and top speed parameters are both numbers, but the only necessary change is simply changing the type from string to number. But do take notice that the type property is a string, and that we are only changing that string value from the word string to the word number. That's it. We can now close the properties object, but there is one more property we need to add to the parameters object. This is the required array property. Here, we let the AI know which parameters are required for the function to execute. For our example, we'll set the required properties to carName and top speed, leaving the year as optional. And that's all there is to adding a function. Go ahead and add as many functions as you'd like to your tools array, and when you're done, be sure to have all your closing brackets in place and you're done adding in your functions. However, before we compile and run the application, we are going to talk a bit about the messages in this situation. Now, we'll discuss how the chat completion's messages array object can help the AI know when to call a function. In our example, we'll continue to use the getCarInfo function. Understanding how the AI determines to call a function or not is crucial for effectively leveraging the function calling capabilities. From our earlier chat completion lesson, we know the messages array in a chat completion request plays a pivotal role in guiding the AI's behavior. Each message in this array has a role and content, which collectively drive the context of the conversation. For instance, consider a scenario where a user is interacting with the AI to get detailed information about a road trip they're about to take. The messages array might look something like this. Your system role has the following content. You are a knowledgeable assistant who can provide detailed information about routes for long road trips and determine gas cost, optimized routes based on terrain, potential maintenance issues, and time en route between points. Next, you provide a user role with the content. What is the quickest I can get from New York to San Diego driving my vehicle? Given this context, the AI will process the user query and determine whether it can provide the information based on its training data, or if it needs to call an external function to retrieve some specific details. In this case, it's likely the AI will need to call the getCarInfo function to provide accurate information about the user's road trip. For example, it may need to know the car model. This can matter for the vehicle's reliability reputation and how frequently it needs refueling. Also, the year may be relevant. If the vehicle is older, it may be more likely to require maintenance along the way, and if it's too old, parts may be difficult to come by. And finally, what's the vehicle's top speed? Though the AI may not know if you have a lead foot or not, the difference in planning a road trip between a moped and a Lotus could be substantial. Also, routes may be significantly different if you're driving a semi-truck or family sedan. Regardless of the specifics, the AI will need additional information, likely from the getCarInfo function, to determine accurate information and provide a detailed response for the user's road trip request. Next, using a different function example, we'll set up our application with the OpenAI API function calling feature and see how the AI will instruct your application to call an external function with the necessary parameters. Okay, back in our code, let's go into our main.ts file and set up the function call. Here, we have our usual OpenAI setup code and the async main function, and in our main function, we have a standard call to the OpenAI Chat Completion API. The only real difference in this file from the code you've seen previously when calling the Chat Completion API is the addition of a null check. Though this is a minor code update, the reason we have placed it here is significant. The reason is that when the AI determines it needs an external function to be called, it will not send back a populated message with any content. Now that we have our main.ts set up, we'll jump into our defs file in a moment. But let's first understand the example API function call we're referencing. The example we're using can be found at https://jsonplaceholder.typicode.com/guide. Looking towards the bottom of this page, we have the following API endpoints: posts, albums, users. These endpoints then take a user ID, which is followed by either the comments, photos, albums, to-dos, or posts. What we will query the AI for is the number of post or to-do items a user has completed. In our example, we're looking to find the employees we should give merit raises to based on the number of posts and to-do items they've completed. Okay, now that we have covered the API we want to call and what our intention is with it, let's jump back into our code. In our defs file, we will first take note that our response format will be set to JSON object. Remember, for this to be valid, somewhere in our messages array, we must mention that the AI needs to return JSON either in the system, assistant, or user role. We're using JSON because we will review the return data we get back from the AI for the function call, and we will be looking at the JSON format and not the plain text format. Next, we will look at the messages array. Here we see that the system role is set to provide JSON output and that it helps us evaluate our employees' statistics. Next, our user role states that we want to know how many posts and to-do items a user has completed and, if possible, to provide a user ID. This relates to our API function call, and we help the AI's understanding along the way by providing good descriptions for each element of our available functions and associated parameters. Now that we have our formatting and messages set up, let's take a quick look at our current OpenAI configuration object. First, notice that we have removed all but a few elements set in our configuration object. This was done so we can concentrate on the function calling features, more specifically, the tools property. Know that even though we've taken out a lot of the chat completion properties, all the properties are still relevant and behave as before. But again, we've stripped them out to focus on the function calling features. Now, let's add in our tools array to our configuration object. Here, as mentioned, we have the tools array, the first function schema, and in this first schema, we have the type set to function. This is then followed by the actual function object. Now you'll see that we name the function getUserStatus and provide a description of what the function does. This is exactly as we have discussed a bit earlier in this lesson. Next, we add the parameters object and set the type property to the string object. Remember, the asConst is a TypeScript-specific component which enforces TypeScript's strongly typed rules. Next, we add the properties object which holds the parameters we will pass to our function. Here we have three parameters. 1. Endpoint. This is a string and corresponds to the first element of the API, either posts, albums, or users. 2. Endpoint element. This is another string and corresponds to the API's component for either comments, photos, albums, to-dos, or posts. 3. Element ID. This is a number and corresponds to the ID we'll use for the user ID component of our API call. Notice in the messages object, we state that the default for this is 2. And finally, before we close the properties object, we add the required array property. Here, we set the required properties to endpoint and endpoint element, leaving the element ID as an optional parameter. Let's take a moment to review the tools array in its entirety and look it over in isolation to help enforce our understanding of the property. Here we can see all the elements we've discussed and how they fit together in the tools array. Next, let's take a look at the full OpenAI configurations object with the tools array added. Again, we see all the tools array properties, and additionally, you can see how it all fits into the chat completion configuration object. Now that we have our configuration object set up, go ahead and compile and run your application. Instead of a standard response from the AI, you'll receive a JSON object with the function's name and parameters. In this lesson, we revisited the chat completion API and looked at preparing the function response and the tools array to pass the function's information to the AI. In our upcoming lessons, we'll dive deeper into the function calling response and continue to expand our understanding of OpenAI's capabilities. This completes our lesson on the function calling workflow in the OpenAI API. Stay tuned, and let's continue enhancing our AI-powered applications together.